I think we've beat that one to death.
That's our job. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Al Williams.
This is episode 220. This week we'll be talking transparent ice, fake aliens, and bendy breadboards. This week in the news, we've got two Hackaday contests closing up really soon. First off, the Hackaday prize. If you are entering into the assistive challenge, this is your last weekend. If you've been working hard and just haven't done your I.O. page, well, you know, you're in good shape. If you haven't started yet, it's going to be a long weekend. Those of you who are doing analog stuff, though, and entering the op-amp challenge, you've got yet another week. The final day for that is Tuesday, June 6th. So you analog folks, you've got 2 weekends. Assistive tech folks, you've got one. And that, of course, also means that we will get into the third round already of the Hackaday prize. And that's going to be green hacks. So anything kind of environmentally friendly. So if you've got a green hack warming up, you can't enter it until Tuesday next week, but get ready to go.
I'm confused. Do you mean my robotic Kermit is not going to be eligible?
Not until next Tuesday.
It's not easy being green.
This is a journey into sound.
What's that sound?
What's that sound?
And then that'll bring us to the What's That Sound contest. This week is a drawing week, so have a listen to the sound real quick, Al. Give me your best guess, and then I'll tell you how our listeners did.
Yeah, I don't know, Elliot. I closed my eyes and I got a foggy picture of a locomotive, but I'm sure I never get these, so.
Dan Maloney got this one straight up. He said this is the hammer in a forge, probably a power hammer or something. It's actually a trip hammer, but, you know, any sort of metal forging automatic hammer, I think I'll take it as an answer. So not many people picked this one up. So, you know, no shame there. We got 14 answers, and of them, 6 are right. They go from hammering metal, probably a power hammer, pneumatic hammer, blacksmith noises, automatic hammers. Hammering sounds like a forge hammer. Yep. Blacksmith's power hammer.
Nobody answered MC Hammer?
Oh, man, I would have given them points for that one. We probably would have had to give it to them. A cat trapped in a duffel bag is probably the least likely wrong answer. Making wasabi is fantastic. Oh, Tim W. guessed a train running on a track.
Well, there you go.
You guys are brothers.
I'm not totally gone.
So anyway, here I go. I'm going to roll a 6-sided die, 6 correct answers. That's the easiest possible case. The number is 2. This is Zach. Congratulations. I'll get in touch with you, get your shirt size, and get a Hackaday t-shirt out to you. But I stand corrected. Someone wrote in with the handle hammer time. Hot diggity.
Well, there you go.
You should get extra points for this. 2 guys using hammers to forge something out on an anvil. Hammer time. Good on you. All right, well, if you would like to play again, tune in next week. We'll have another sound for you all to guess. This week's first hack is more news than a hack, but it's a really cool story, so I wanted to cover it. Simulated ET to phone home from Mars this afternoon. It's this afternoon as we're recording this. It hasn't quite taken place yet, but will soon. And by the time you're hearing this, you might have even decoded what the fake ET said. This is part of the SETI project and the search for extraterrestrial intelligence. And one of their biggest concerns is what would happen if we got an extraterrestrial signal? What would it look like? Would we even notice it? And this is it's actually kind of an art project, a sign in space, and they are beaming a simulated extraterrestrial signal at the Earth. What's really cool here is that they've managed to get a little time on the European Space Agency's ExoMars orbiter. And so they're actually broadcasting this fake alien signature at us from Mars, which is just, that's pretty crazy. It'll be observed on the Earth at a number of places, and I guess this is part of basically a test run to see if they'll even hear it. And then afterwards, you will be able to look at the data and see if you can figure it out. And that's going to be the fun part of this challenge for those of you listening at home. I wonder if by Friday it's already been decoded. What's your bet, Al?
I don't know. This is a tough nut to crack. I've written about that before. When Frank Drake proposed the original message they beamed out from Puerto Rico, they gave it to a bunch of people, and I think only one person figured out what it was supposed to be, or at least you presume that because they responded with the same bit pattern as a martini glass. I don't think they ever actually said, and even then, I don't know that you would guess what all the little dots and figures mean, but I think they at least figured out that it was a picture.
Yeah.
So I think you have a lot of problems with that. And, I mentioned in the post, if you were, say, from 1910 and somebody said, hey, there's a radio station today, do you know about FM radio? Do you understand how to decode it? Can you receive stuff at, 100 megahertz? And when you hear an ad for a smartphone or Starbucks, does that make any sense to you anyway? So I think it's kind of odd to think that if aliens are talking, we're going to be able to figure that out. As far as we can tell, dolphins and bees are talking, and we can't figure out what they're saying with any regularity either. And that's probably closer to us than the aliens.
I think you're right. And I'm looking at Drake's message right now, and the one thing that of course sticks out is there's like a human being. And why do people stick out? Because we're people, because we have 2 legs and 2 arms and a head, and it looks like us. But imagine we're 4-legged aliens or 6-legged aliens. That is just going to be random noise like the rest of it. And I've played enough Game of Life that I see like gliders in there and all sorts of other things that I'm certain aren't there, along with
the Conway message,
along with the martini glass. What is that supposed to be? Arecibo at the bottom?
Yes.
It is. Okay, I got 2
things. The middle part's DNA, I think, right? So, but
oh yeah,
not in any way that you could really say it's high res DNA, but
yeah, might be kind of strandy. Okay.
So if you go look at the Wolfram Alpha page that's linked in that post, it lets you look at the data at different sizes of X and Y. And so, if you didn't know what any of this stuff was, I'm sure you could find patterns in just about any arrangement of these dots. We're kind of hardwired to find patterns. And this one looks obvious to us. I'm thinking it would be a great Saturday Night Live skit if Saturday Night Live were geeky enough to say, the aliens get this message, look at it, they say, what is it? And he says, I think it's a menu,
Right? I'll have the beef and broccoli.
They look tasty, right? So
Oh, I see.
too subtle.
My favorite comment here comes from Mike. It's actually the first post. Can't wait to see some radio telescope operators jump out of their seat when they receive the signal, only to be let down when they hear they didn't get the memo.
Or send more Chuck Berry. I liked that one too. So. So maybe that's a future Hackaday challenge, Elliot. We craft a message, and instead of guessing the sound, you have to decode our alien message. So my first hack this week was actually from some MIT folks, and it's one of these things that's not that hard to imagine, but they really did a great job of it, and you think, oh, gee, I should have thought of that myself. The title of the post was Building Circuits Flexibly, and what they've done is they want to have circuits that, say, conform to a ball or a hat or a glove, and they want to prototype them. So we all love solderless breadboards, but solderless breadboards don't bend around a glove very easily. And what they did was they actually sacrificed a breadboard, took the springs out of it, and 3D printed new holders for them that were rigid, but then they used another plastic that would give it flexibility. So it kind of reminded me a little bit of some of the 3D printed chainmail that you see, but it had solderless breadboard springs in it. So I thought that was just really clever. They had all the details on GitHub, so it's something you could go do this weekend if you felt like doing it. I think a lot of the comments on that one were kind of interesting because, some people were pretty receptive, but some people were saying, oh, why didn't you just solder it? But, I think especially in a university setting, when I was in school, there was always this, don't cut the leads because we're going to use those parts again for another class, right? So I can easily see why saying, hey, just solder stuff down is not that great when you're running, 250 freshmen through some lab. But even just for normal, I don't know, I still like a solderless breadboard. It's not that I can't solder, but, when you're just trying to work out the basics of something, having that solderless breadboard's a real game changer. If you think about it, for a long time, we didn't have that. It seems like they've been around forever, but they're really not that mature. There was an article, I want to say in Elementary Electronics back in the 70s, where they made a solderless breadboard. It was really cool. It was literally a piece of wood, and they had copper pipe that they had cut and mounted on it. And the springs for that were actually paper clips bent out with rubber bands holding two paper clips on two different tubes. So you'd pull the paper clip up, stick a resistor lead under it or something, and let go. And the tension from the one holding onto the other pipe would pull it back down. And of course, that was great as long as you didn't have to do an integrated circuit, So there were several systems like that floating around. ICs ruined everything that looked like that.
Yeah.
And so I thought this was just an interesting evolution of prototyping technology.
Yeah, no, it looks really cool. And, like the example of doing something on a glove or doing something on a hat, like it's pretty obvious. Like you say, it's obvious once you see it, but it's pretty clever until then. I'm kind of with the people in the comments. If it's going to move, you're in trouble, because on a good day, breadboards are, my friend Ash used to always call them boards of intermittent connectivity. He was a firm adherent of the solder everything together, at least on a proto board. And that's because he did a lot of radio stuff and a lot of stage rigging and a lot of stuff where it kind of mattered, and and getting it done mattered, right? Getting it done and getting it done right and having it stay. I could totally see this on the back of the glove. The little DuPont pins are wiggling their way out or flexing in and out. On the other hand, so cool looking, and you can cast shade on the boards of intermittent connectivity, but you still got to use them at the end of the day.
It's hard to find, but if you look, you can actually get the little terminal strips that are just the springs, like one spring. So if you've ever seen the solderless breadboards where they have a function generator and there's the little strip of, 4 holes that are the output to the function generator, they make those.
Oh,
so
cool.
I was thinking you could actually do that with those, but just kind of put them together in a fabric or a matrix, but they're really hard to find. I used to have a source for them. I don't know. I haven't bought any lately, but you could never go to Radio Shack and buy those, and you got to kind of know the nomenclature to find them in distribution. So
God, really cool. If anyone out there knows what they're called, let us know. My next hack comes from Damien Dolata. It's a video progress report on a hoverboard he's making. This one, hoverboard rides on eddy currents, shows his progress toward making a magneto-rotational repulsor, which sounds like Iron Man would use it, but it's actually a 3D printed rotor with a bunch of alternating North Pole, South Pole, North Pole, South Pole magnets. You spin this around really fast over any conductive metal surface. Here he's using aluminum because it's really conductive. It makes eddy currents in the aluminum. They repel the spinning magnets, and boom, you're hovering. Sounds really easy, but if you look through this video, there are all sorts of fails of his earliest projects, and you can also tell by how happy he is when it actually starts to lift up. It's sold as being his first human levitating test, and he does get it to pick up 30 kilograms. But for those of you in imperial units, that's the weight of a 9-year-old, 10-year-old child standing on this thing, and not the weight of Damien himself. But it's pretty cool, and the thing does make a heck of a racket, and it does levitate kind of 2 centimeters up, even with his son and daughter standing on it. So kudos to him for making this thing work.
I don't know. I didn't think Iron Man. I was thinking that sounded more like Star Trek tech speak, right?
We need more dilithium crystals for the magneto-rotational repulsors.
What a great piece of work. I really like the turbines on the back of it. So presumably once it's hovering, you still got to have some way to move, which is always the problem with hovercraft in general. But what a neat thing. Of course, the Back to the Future comparison's inevitable, but I think it's kind of sad that, the industry has conscripted hoverboard to mean the self-balancing scooters, which are really not hoverboards. And it's kind of sad. It kind of takes away from the idea of hoverboard, I think.
Yeah, no, that's an offense against man and nature. Actually, Brian mentions that here. He says that quote, that hasn't stopped anyone with a unique personal vehicle from using the name anytime they need some quick marketing. Nice snark, man. But This is one of those things that's technically possible, but really difficult, but it's just so enticing that you have to try it. And then I fear once you get success, it's going to end up being underwhelming. And I hope this doesn't happen to Damien. I hope he can get himself an infinitely large aluminum surface to try this on, because other people have done this before, and these actually both came out of the comments. Someone mentioned the Hendo board, which was, I guess it was a Kickstarter for these things. They weren't actually trying to sell them for skateboards. They were trying to sell them for levitating other things. But they, as a demo, built a copper half pipe, quarter pipe, and they got Tony Hawk to step up on it. The Hacksmith also did one a few years ago, also levitating over aluminum. What these have in common is that none of these things are skateboards. I mean, skateboards have wheels on them, and that lets you go in a straight direction. These things go sideways. Like, you can't push it in the direction you want it to go. And Tony Hawk is the best skateboarder I know, and watching him make a fool of himself, continually falling on his butt because he can't get any purchase on this thing, is worth the price of admission just by itself.
Well, that was one thing I thought when I saw the turbines, as cool as they are, they're really going to provide vectored thrust, and, you'll be able to push a little bit to the right, a little bit to the left. But it seems like the model here would be more like a standing quadcopter, that you really want Kiwi drive, if you will, but with thrust vectors instead of friction wheels.
Cool.
It seems like that would be more, a little vision system, and then you could go straight, right? Because you'd put enough jets into it to keep it straight, however it was going to go. But I do think there'd be, if you could actually make this work and work cheaply without cryogenics and all, like the Lexus board, the commercial possibilities would be opening an arena for this, right? And you say, okay, for $100 an hour, you can come take the class, and then you can fly the hoverboard around. And skating rinks, that they made a living doing skating rinks and still do, I guess. I would think people would pay to do that.
The other thing that comes out of the Hacksmith demo is that these things put so much eddy currents into the aluminum or copper or whatever the repelling undersurface is that it gets super duper hot. And they at least have a fun time by cooking eggs on the aluminum plate. So they actually flip the whole setup upside down, hover the aluminum plate over the board, and then use it to make sunny side up eggs because it gets that hot. And if you remember last week, we were talking about Tom Stanton video where he tried to use the same effect to make a transmission in a bicycle, essentially. And he concluded that the copper disc got horrendously hot by the end of it. And I think that's going to be the case here. On the other hand, if you're in a skate park that's covered in aluminum, maybe you got plenty of surface for it to dissipate off of.
The next post I wanted to talk about was the Wizard of Semiconductors, and it's a piece of software called SillyWiz. You can run it in the browser or you can download it, and it's kind of related to the Skywater PDK, which we've talked about. That's the open source process for having custom chips made. Elliot, I've said a million times, you don't really have to know how an engine works to drive a car, but you can bet at the Indy 500 every driver knows how the car works. And I think this is kind of in that direction. You can do a lot of electronics your entire life without knowing how ICs are fabricated, but it's probably pretty good to understand. And this is sort of the 5th grade level understanding of how that works. So if you kind of look into the documentation for it, the Skywater PDK has got, 50 different layers or something, and they all have specific uses and meanings. This one has 6, I think, or, some relatively small number, but it is compatible with that idea. And so it's kind of almost a video game. You draw out your diffusion, and then you implant N layers and P layers, and there's polysilicon and 2 layers of metal, and you have to have vias, but it's very approachable. And there's actually a very nice tutorial that walks you through making different things out of those basic elements. I always find that very interesting. I actually spent a lot of my early career doing failure analysis on 8-bit microprocessors for, let's just say, a big semiconductor company. We had to work with all this, and at the time, that was really something I didn't understand. So I spent a lot of time having to figure all that out. And the IC world, you would think it's just, it's Raquel Welch gets shrunk down and put in a little submarine, but it's not. It's very, very different. For example, in the real world, we might have precision resistors, and those are relatively cheap and very high precision, especially if you don't mind paying for them. On the IC die, resistors are terrible, and you can't depend on their values in any way unless you go measure them and then trim them with a laser, which of course is pretty expensive. Because it's a photo process, things like the ratio of values of capacitors, where the thickness between, the thickness of the glass and the XY dimensions of the piece of aluminum that makes up the plates of the capacitor, they're very precise. So I don't necessarily know what the value of that capacitor is, but I know it's twice the value of that one or half the value of this one. So that turns out to be the things you design with. Now, this program's not going to get you that deep into it, but it does give you a start on what all this technology looks like at a very, very low level. The truth is, most people don't work at that low level anyway, because if you ever see real ASIC designers, they usually have a cell library. And so it's almost like we will buy an op amp and not design an amplifier and just stick it in there. You'll take a cell out of your cell library and put it down there. But inside that cell library, this is the kind of thing that's going on. Same for even an ASIC or an FPGA. A lot of times now you'll just use a high-level language like Verilog, and you'll describe what you want, and the computer's going to figure all this out. But again, it's like the race car. You don't have to know how the engine works, but it really is good to know. And I think this is a pretty gentle introduction to that topic.
Yeah, anyone who's ever followed any of Ken Shirriff's teardowns and super die shots and annotations where he's going through all of these famous chips of the 70s and 80s and explaining how they work at a gate level, following along with that is one thing, but this is an interactive online tool. You can just draw these layers out and be like, have I made a transistor? What have I got here? And more to the point, you can make the gates wider or thinner, and you can see what it does to the capacitance, and you can see what it does to the current they pass through them, and you can see what it does to the gate voltage and all sorts of stuff in this kind of really very easy, approachable, just drag and drop web interface, real time, just recalculate it out. And I think that's, for me anyway, the coolest part of this is that looking over Ken Shirriff's shoulders, no matter how good a job he does, or Zepto bars, or no matter how good a job they do at documenting everything in the chip, there's also something about just going in and playing with it and saying, what if I tweak this? What if I tweak that? So this project, and it's mostly written by Yuri Shaked and Matt Venn, who are Hackaday super friends, is just really, really, really cool. And like Al said, you don't have to want to make your own ASIC to want to play with this. And if you want to make your own ASIC, you might even not want to play with this. But for your education about how the most kind of fundamental building blocks of our modern world work, it's more than worth your time to play around with this software. So I think that's really cool and much worth your time.
I really wish Ken would show us his lab, because he does the kind of things I used to do back in the 80s in a bazillion-dollar lab for a Fortune 100 company.
Yeah.
And I'm sure he does not have all that. So I'm always curious, what are you doing exactly? I used to actually train people to do that. But, like I say, we had equipment that even today would be fiendishly expensive and difficult to get, in electron microscopes and, lapping wheels. And we also had a lot of very talented people. There was one guy, you could give him a contact that was a micron and say, I want to cross-section that contact in this plane. And he would say, do you want the first third, the middle, or the last third? And he wasn't kidding, right? He could really get it to that level.
And my last hack this week, ESP Clicker, an elegant solution for integrating dumb devices into Home Assistant, is a simple project by Priceless Toolkit. And all the files are up online, and you can just get it printed out right now. Like I said, not much to it, but it's devilishly clever. What it is an ESP8266 and a few, I think 3 relays, and then a bunch of wires in a nice pigtail. What can you do with this? You can hook it into your home automation system and turn any of those 3 relays on, turning on whatever devices you have connected to it. And the idea here is to just make an incredibly simple widget that then you can go around your house and find the buttons in some device you'd like pressed His motivating example is a coffee machine, and then you just solder the two wires onto that thing, and boom, it's part of your home automation system. And I think that's just really very clever. Like, this is the kind of hack that will help people who aren't necessarily hardcore hackers become able to, smartify the devices they want to smartify and smartify them in exactly the way they want to. Really, really cool. And it talks MQTT and it's compatible. Of course, it's all open source, so you can make it do whatever you want, but it uses the ESP home environment, which means you can then flash it over the air, and it's just all sorts of convenient, dead simple. It's the sort of thing that you could give to someone who really knows just how to solder and find two terminals of a button, and they'd be able to turn a device into a tool of home automation.
So I almost picked this one myself, Elliot. It was, like you say, it's certainly an enabler. And it really made me think of the commercial product, the SwitchBot. Have you seen the SwitchBot?
Mm-mm.
So it actually, the reason I know this, I've got a really nice, I call it the lab, but really it's more like a shop. It's a freestanding building. And it's got a little door on it that doesn't have a good facility for putting a normal deadbolt on it. So I had to kind of work it out to where I had the surface mounted deadbolt. And they make a smart lock that it's literally an Oldham coupler and a motor, and it attaches to your door. And when you lock the door, it twists the knob just like you would, right?
Right.
Or if you unlock it, it twists it the other way. And it turns out that's how I became aware of them. But they have all these other products that, like, you basically put a little robot finger over the switch. And when you say turn on the coffee pot, it jams the switch with the little robot finger. I don't know how practical that is, honestly, and I've never actually seen the button pushing one, but I will tell you the door knob one, it's not ideal if you have an option, but for a lot of things where you've got a case like mine where the lock's not really compatible, or like if you were a renter and you don't want to take off the door and rebuild the door, it's probably a good idea. So this kind of struck me as the hacker version of that, right? Here's a relay. Yeah. You can turn it on and off easily. And if you're smart enough to go solder it behind the contacts of a real switch, then you can use it. I really liked it. I thought it was a great idea. It's one of those things, it's, again, not something you couldn't think of, but once you see it, you're like, oh, that's a good idea. Why didn't I think of that?
Actually, when we're saying this, I just realized that I have a device that is essentially this, only with two relays that I installed down in our basement, actually controlling the heater in my actual home. It turns the furnace on and off, and it switches it into daytime or nighttime mode, because we have one of those stupid timer things on it, and it went busted, and getting a new timer was like $100. And I'm like, oh, well, screw that. It's just a couple relays. I will solder an ESP8266 to it, make my own relay board, and boom, it's connected to our home automation network. And that was easy for me to do, because I can just, etch my own PCB board and do this, quick in the house. But for people who can't, boom, this is exactly the same solution. And it solves a real problem. I just love it.
So my last hack was Laurie Griffith's bringing the PIO to the FPGA. I had kind of mixed interest in this. The Raspberry Pi 2040 has the PIO, which is basically a little dumb processor that you can say, hey, go generate PWM on that pin and then go do that forever while I go do something else. So very limited subprocessor. And the idea was to take the Raspberry Pi spec for that and reverse it back into Verilog so that you could put it into anything. Well, yeah, it's a great idea, especially if you had something already using PIO and you wanted to put it on an FPGA. Great. That makes sense. It would be a lot less work to have this ready. On the other hand, for most things that you want to do like this, if you're on an FPGA, you just build your own little circuit that does whatever that is, counts pulses, right? Does PWM. So I'm not sure the utility in a fresh design is that I want to use the PIO in FPGA. Maybe I missed something, but that's kind of the idea of using an FPGA is I don't have a central processor, or if I do, it's because I put one in there and then I put other stuff in there too, like PWM generators. It's not a new idea, but I think it's really got more mainstream with the Raspberry Pi. Parallax had the propeller, And it had kind of the same ideas where you don't have to emphasize interrupts so much if you just have, n number of processors. And so instead of saying interrupt me when that signal changes, I can just set a processor to watch it and then go off and do other things. I think it's a good idea. And for processors especially, there's plenty of, say, flight hardware that has, back in the old days, you'd have a PPC main processor and you'd have little x86, 8086 type processors to do I/O, which of course those are quite capable. I don't know. For an FPGA, it wasn't clear to me this was something you'd want to embrace for a new design, but for porting, I think it could be really a good thing. And it's certainly an interesting exercise either way.
I think, Al, you and I are basically Hackaday's two FPGA holes. I mean, we are the people who like playing with them. What I felt when I first saw the Raspberry Pi Pico was that's awesome. They strapped these tiny little FPGAs onto the thing so you can finally do some of this in a microcontroller. And, they are just little, they're little state machines basically. And you can just run 8 commands on them, but you can do it fast enough. When would you want to do this? I think you started off with it. It's the reusability of code. And so if you're already throwing a soft core in there and then you want to emulate basically an RP2040 in an FPGA, the only thing you're missing is the PIOs. And so now you can just throw those in too. Or it's just for fun and would be a really cool thing to try out. I don't know which. Code reusability or just fun to see how they work on the inside. I'm sold either way. My 3 quick hacks this week are all videos you're going to have to watch, so settle in this weekend. I'll start off with 2 SuperCon videos. One, Andy Geppert is bringing core memory back. In this one, he shows you how to weave core memory, explains how it works, and then shows you his Core 64 project, which incorporates LEDs beneath the cores so you can actually write on it with a magnet. It's a really super cool demo. Core memory is weird, and after watching this video, you'll understand it. Next up, the second SuperCon video, Nick Poole makes a Jolly Rancher tube. This is the story of his imaginary company, Integrated Thermionic, which presupposes a world where there is no silicon and integrated circuits are made out of tubes. Nick is playing around making his own vacuum tubes, and in this one he really does make a diode with a Jolly Rancher-shaped anode. And last but not least, a video coming from Deutsche Welle Planet A. Keeping the Noise Down Under the Sea. That's a really neat short documentary about 3 different ways that we're trying to keep aquatic noise down. And so if you think about driving piles for undersea drilling platforms, they make a lot of noise. Ships, it turns out, cavitation of the fan blades makes a lot of noise. Marine surveys, they use air guns to listen to the reflections that come back at them. Those make a lot of noise. And so this video is documenting 3 different ways that we can be kinder to the animals that live underwater that have ears and are getting deafened by this. It's really cool tech. It includes bubble curtains for the pile drivers and VibroSize, which is using controlled higher frequency vibration for the seismic surveys. Really cool video, and you'll learn something about being good for the planet.
Okay, my 3 for the week, with a 1,000-year radioactive diamond battery. There's a commercial company that has a carbon-14 battery that actually the carbon-14 is trapped inside of a diamond, and it produces a little bit of power, a very little bit apparently. But the good news is it lasts a very, very long time. And the company asks, what would you do with a power cell that outlasts the device it powers? And I thought Jenny's comment was right on, which was to which we hope the answer won't be throw it away to be a piece of orphaned radioactive waste. But that seems really likely. So I don't know how I feel about that. And I don't really understand how much radioactivity is in the battery. But, if it's Timex watch glow in the dark dial, that's probably not a big deal, but I don't know. The second one I had for this week, remote-controlled hypercar slices through air. That's a project by Indeterminate Design. It was just really cool. The aerodynamics, we think about that a lot for aircraft, but it really is important for cars, and I guess even remote control cars. It reminded me a lot of the piece we did about a month ago where it was talking about the car makers making the clay models of the car, which I thought was really interesting. I'll throw the link for that in as well. And the last, but certainly not least, was Jaw J, I guess, doing watch a web page fetch itself over TLS. So, you know, the old joke about the first rule of Tautology Club is the first rule of Tautology Club. This is a page that loads itself over TLS and shows you what it's doing at every step of the way. And I think there might be some gloss over because I noticed on the GitHub page it does say certain liberties are taken or something, and it didn't really explain what those liberties were easily. But if you don't really understand what's going on an SSH connection to your bank, or wherever you're doing an SSH type, or excuse me, HTTPS connection, it's pretty illuminating and a really good thing to spend a few minutes working through.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. And this week I'm picking Maya Pasha's AirTags, Tiles, Smart Tags, and the Dilemmas of Personal Tracking Devices. And this is a really great analysis of kind of the state of play with all these little personal tracking devices. Basically, you just want to find your keys or your backpack or something. And so they invent this Bluetooth system that then talks to every phone in existence and tells you where this thing is. You know, to find my backpack, I mean, it's overkill, but it kind of works, right? The problem is when people start using them to track other people who don't want to be tracked. Then you're using this thing for a crime. And the question is, how easy is it to do that? And what can the companies who are making these do about it? This was spurred by a draft proposal by Apple and Google working together, writing to the Internet Engineering Task Force to see what they could do about making these things less easy to abuse. And I think I agree with Maya here that their conclusion is, you know, we'll make it beep when it's following the wrong person. And Maya says, well, the bad people just pull the beeper out. And yeah, duh. That's exactly what's going to happen. Or worse, you'll use some of the open source software projects that spoof these things, and you'll make your own that doesn't have a beeper in it in the first place. I mean, I think Maya's conclusion here at the end is this is trying to make water not wet. This is trying to make a technological solution to kind of fundamentally a human and behavioral problem. Like, people should be respecting each other's privacy and not, you know, not stalking each other, but also just not tracking people around. And the fact that these devices make it so easy to do and they lower the bar is kind of what the problem is here. Yeah, I don't think there is a solution at all. Comment I want to read from this comes from Dandy, who used to work at Tile as a firmware engineer. And he says, of course they were concerned about every privacy issue, and they just didn't have a solution for it. And he says, feather in Maya's cap, this is one of the most balanced and technically accurate articles on the topic that I've ever read. And yeah, I think so. I think she hit it just right.
Well, this was a really thought-provoking article. And, you know, I agree. No matter what you do, you can require people to have serial numbers on guns, but then people file off serial numbers, right? Or, you know, that whatever thing you're going to do, somebody's going to undo. For example, the fact that they just talk to other Bluetooth devices means you probably could have an app on your phone that says, hey, 28 trackers have pinged you today, and I happen to notice this one's pinged you 35 times in the last 2 hours, so it must be somewhere near you a lot, right? So then maybe I know your Bluetooth ID and I exclude you, right? I mean, there's always going to be some way to get around it. And probably the people you want stalking you the least are the ones most likely to be able to not be detected.
Yeah.
I hate to say it, and I don't want to promote this as my personal view, but I fear that we may just have to accept that one day you just will have no expectation of privacy, right? You already have cameras everywhere. You have facial recognition. You've got, already, I know in Houston, and this isn't sinister, but they watch your Bluetooth MAC address on the highways so they can figure out the traffic. They go, oh, this MAC ID went by at 8 a.m. and then at 8:05 it went by this other spot, so it took 5 minutes to get from here to there. And they don't, as far as I know that ID belongs to you. They just know it's, the same ID. So I don't know what the answer to that is because I don't like that. I'm not trying to say I think that's a great idea, but I am saying at what point do you just throw in the towel and assume you have no expectation of privacy?
I think Maya almost hits it here, actually, the answer to that question, which is you weigh the benefit and the costs. And I'm trying hard to figure that out for myself here. I mean, Maya does conclude the piece with, and all this because we just wanted a good way to keep tabs on our keys and a backpack, right? And I think maybe that's the point. When the damage to society outweighs the good, and, the good is something trivial, like I'm able to find my backpack, and the damage is people are getting stalked. If that stalking is happening a lot, then you say, well, this is more bad than it is good. We're going to stop doing it.
But I always say there's no actual new crime, right? All the crime that we think of as cybercrime has been going on for centuries. People have misrepresented their identity. They have stolen. They have defrauded. All these things that you do online happen in real life too. They just happen more slowly and with a lot more work, right? It's just made it easier. And I think it's the same thing here. People have stalked people from probably the beginning of time. This is just going to make it that much easier.
The other recent history Bluetooth tracking proposal was the Corona contact tracing apps, and they went to extraordinary measures to make a rolling code so that your ID never showed up twice, and it was anonymized, and nobody could ever tell when you were around them just by listening to the Bluetooth low energy pings that the apps put out. And they put these incredible anonymity guarantees into these apps. And then you look at this thing where your stupid Tile or AirTag is just putting out the same number every time. And it's like, if somebody knows which tag you have on you and they want to follow you around, boom, they can. And so it just seems slightly schizophrenic to me that when, you're trying to put out a public health app that will help people realize they've been in close contact to somebody with a disease, it's like, oh, let's take care of anonymity there. And when these same companies, because, that was Google and Apple proposing these apps, makes their own product, they're like, bah, it'll just put out the same number all day, all night.
We could riff on the identifiability of typewriters and photocopiers, but I think maybe that's enough. So.
I think so too.
Well, my pick for this week was Lewin Day's The Art and Science of Making Beautiful Transparent Ice. And at first blush, when I first saw this, I said, well, I hate to say like the comments, but that's not a hack, right? It's making ice. But wow, there's a lot to make an ice. And it's one of those cool things that you just don't. It probably should have been a tech in plain sight column because it's literally tech in plain sight. You make ice all the time and it's totally invisible because it just comes out of a spout, or in the old days, you put a tray in the freezer or whatever. But the main thing is your ice is cloudy because of impurities in the water and dissolved gases in the water. And people have all these techniques for getting all the impurities out or getting everything to go to one side of the ice where you can either take it out before that part freezes or, erase it by, heating it up, cutting it, whatever. And then they go on to making molded ice, and you can mold limes into it and cherries. And, I like the line, we've even seen a spiral cut lime skin delicately frozen into a clear ice ball. If you're looking for a way to justify charging $50 for a cocktail, this is it. So I just thought as a piece of art and a piece of science, it was a lot more to it than I thought. Really cool couple of videos, a lot of technology that I wasn't aware of that I have a feeling goes back a long way. People probably have known how to do this much longer than you would guess. So that was my pick for the week.
Click on through to the spiralized lime one if you haven't. That is such a beautiful object.
Yeah, it reminded me of, well, here's for the green contest. It reminded me of green Jupiter, right? So.
Yeah, totally. Yeah, it looks like some kind of a planet. It looks like you should hang it up somewhere, but of course it'll melt and Get lime juice all over everything.
Yeah, if you look at that picture, you can't help but think Captain's Log, Stardate 4432.6.
Yeah, yeah, right? It looks like it's a sci-fi drink.
Orbiting planet Lime.
An M-class planet. It's such a great article, and I didn't realize that all it took to make clear ice was to just directionally freeze it so that the impurities get squeezed out the other side. And that's actually the revelation here for me. I had a friend who used to work as an architect with the Ice Hotel in Sweden, and they have ridiculously clear ice there, and they get it out of a river. And I think it's kind of the same thing at work. I think it freezes top down. One of the tricks here is to do it with a thermos, so it freezes, literally from the top down, and all the impurities then are stuck at the bottom, and you just get rid of them. Maybe put a false bottom in the thermos, maybe you just cut that part off. I think the same thing is happening in the rivers, right? Like they're freezing from the top down and maybe getting rethawed as warmer bits of water come down and then refreezing again. All the air bubbles and all the trapped whatever crud in there gets frozen out the other side, and you end up with just a really nice clear ice.
It did strike me this would make a good hack, right, is to have basically a tray of water insulated with some kind of sensor and refrigeration through like a Peltier or maybe, gas refrigeration. And as it freezes, you say, okay, I'm 2 millimeters from the bottom. I've detected that, so I'm going to beep and stop, right? And then you can just peel the clear ice off and then dump your wastewater. It seems like that wouldn't be a bad hack, and I'm sure we would feature that if somebody would send us that on the tip line.
Oh, you could 3D print ice molds that have a little hole at the bottoms, for the bad stuff to go out, and you can print them in lens shapes and stuff like that. Because this stuff is that clear, but everybody here is making squares and dumb shapes, or spheres are pretty cool. But you could intentionally make ice optics.
Ice, baby. We've done MC Hammer. We might as well give him equal time, right?
Man, Hackaday plays the classics, ladies and gentlemen. Lewin started this off by saying, we all know how it is when you make ice. You just throw water in the freezer, forget about it. Then you throw the frozen, misshapen cubes into a beer and enjoy the literally ice-cold beverage.
I saw that.
Lewin, you drink beer with ice cubes.
Yeah. Yeah, there was a lot of comments on that, too.
We have to talk.
Yeah. It's bad form.
That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you want to join in the comments or follow any of the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, send us an email, tips@hackaday.com. And until next week,
keep those hacks coming.
Lousy.
I'm not in my container for Hackadays.
I hope to hold it together. Let's see. Bye.
Oh, I'll start over one more time.
Take us home.
I can't believe neither of us picked Smart Pants sound alarm when your fly is undone.
Yeah, beep, bail. You don't think you could pull off Brenda Breadboard? I totally could. Bendy Breadboards.
Bendy Breadboards.